So, hello everybody. Today, in this section, we are going to talk about the 26th problem in Project Euler, which is this question. So, let's take a look at about these questions. Okay. Reciprocal cycles. A unit fraction contains 1 in the numerator. So, the decimal representation of the unit fractions with 2 denominators 2 to 10 are given the following numbers, which are displayed here. 1 over 2 is 0.5. So for 1 over 3, you can't divide it completely. So the answer will be 0.33333 and 1 over 4, 1 over 5, and so on. For this, actually the bracket here, which means that the number is repeated, which is stated here. 0.1 bracket 6 means 0.1666 and has 1 digit recurring cycle. It can be seen that 1 over 7 has 6 digits recurring cycle, which is stated here. So which means that 1 over 7 is actually a list. Okay. So the pattern will be like this and so on infinitely. And 1 over 8 0.125191 0.11. So find the value of d which is less than 1000, which 1 over d contains the longest recurring cycle in its decimal fraction parts, which means that in this sample from 2 to 10 we need to find the maximum recurring cycle, and we found that it is 7, but from 2 to 1000, which we are going to ignore 1 here. So it starts from 2 to 1000 because 1 over 1 is 1. So it doesn't have any recurring cycle, or maybe I just say as 1 because it is 1.0000000. So we can just say as 1. So here's the solution. But before that, I will show the operations to get the answer right. So as you all know, we have remainder and quotient in division. So the operation is actually like this. Let's say we have 6, right? Okay. So for the first part, we put 0 point something. And then because 1 cannot be divided by 6, so we add a 0. This is pretty simple divisions. So we put 1, so here we get 6. Okay, 4 cannot be divided by 6 again, so we add a 0. Now we add 6, 36. And we get 4 again. We add another 6. 36. So this is pretty tricky. So we'll add again. So as you see, if the remainder are the same, which means that the cycle will go over and over again. So let's take a look about 1 over 7. Okay. So we put 1. So this is 7. This is 30. 30, and we put 4, which is 28, and again 20, we put 2, and 14, so we'll get 6 again, so 6, we put 8, 56, 40, and we put a 5, 35, and this is 50, and we put a 7 here, so we got 10 back. So from this result, we will find that after 7, the cycle is going to start again because the remainder are the same, and we are going to repeat this stuff again, these parts, the complete here. So I will change this algorithm into code, which is data here, integer max. For this integer, it stands for the maximum recurring cycle that we have found so far. And then we start with the number 8. The remainder occurrence for this array is to store this number. The position for this number, let's say 3, the position should be 1. The position for 2 is 2. So when we divide, we check for the remainder. If the remainder exists before it, which is like this, the position is 0, right? So this is 0, 2. So when we check, then we can use the difference in place to get the number of recurring cycle here. So if it occurs here, then we know the place for this number to occur, and we know this too because we have an array to store the position for the first occurrence of this number. So we can just minus it. That's it. So place, this is the current place, and remainder. So I set it to 1 to for this loop to work actually. So it doesn't matter if you set it to other numbers other than 0. I just want this loop to work. You can set it to 999 or whatever numbers you want. It's fine. So next we start dividing it. So remainder occurrence, remainder which is 1. That's here. The first one should be 1 because sorry, for this you should set to 1. I forgot about it. Because of 1 occurs here for every single instance, it is still 1 because the numerator is 1, so the 1 should start first, and then for this we get the remainder, which is 10 and remainder of 7. So next we have, if you have 30, right? So we just times 30 times 3 with 10 and divide by 7. Same with 30, 60, 35, so that we can get the remainder here. And that the loop will goes on and goes on again until the remainder equals to 0, or we found that the remainder has previously occurred. So let's say about this case. This case is for the case something like this, 1 over 4, 0.25, and then after that the remainders will become 0. So the loop will break. So for the second case, which is which this is the case that we have discussed before. Something like this, 1 over 10 and 10. So if such case happen, then the loop will break. And now we have found the maximum recurring cycle. Sorry, the recurring cycle for this number, and then we compare it to the existing maximum recurring cycle that we have found, and if the maximum number is less than the recurring cycle of current number, then current number will become the maximum recurring cycle. So basically it's comparison and set it to the higher number of recurring cycle. And the last, after looping through from 2 to 1000, I'm using 8 here because I know the number should be somewhere after 8, the maximum recurring cycle. So it doesn't matter here. If I set 2, it works 2. So finally, we display the number d equals to max plus 1. The max plus 1 here, which means that because here, this is 0 place 1, place 2, place 3, place 4, place 5, place 6. So we'll minus it. And in the end, we plus 1 to take care about the place, because initially 1 to 6, the place is 1, and if the place is 6, there should be 6 number instead of 5 number. So this is the reason that I add 1. So let's run. D equals to 983, which is the same with the answer here. So this is a solution. So see you guys next time. Bye bye.